Hi my friends. Today we continue with presenting iLogic for assemblies. This is an assembly and we have to recognize its components: crossbar, pole and base, each one in two instances. The dimensions are named: length, width and height, and the prefix AS is for assembly. These are dimensions for assembly because length, height and width will have each component here. When this will be created, we'll use iLogic to create rules and forms through which we will be able to control both the whole and its components. But let's start by presenting the results. This is the result. We'll have this construction and a beautiful dialog box with the name modular stand. You see here assembly length 150. Dimensions are in centimeters, not in millimeters. When we select another dimension, instead of 150 we select 120, you see this stand will be changed. The same for height and the same for width for this length. So we can control between some limits this assembly. Let's see how to do this. We start by creating the assembly. You see here how to create this assembly. It's not a big deal. You can download components, base, pole and crossbar by reading the last paragraph in the description of this tutorial. I have to present these components because we don't create them right now. This is the base and it has a parameters table here where you see D0 is the thickness, 3 centimeters, width 10 centimeters and length 50 centimeters. Thickness, width and length. The next is the pole, which has this definition: thickness the same 3 centimeters, width 8 centimeters, width and length 80 centimeters. The last is the crossbar, which has a similar parameter table with thickness, width and length as special parameters. What you have to know is that the values of these three parameters comes from the assembly to the component. You cannot write here any expression by thinking that the expression would be calculated in this procedure, general procedure with iLogic. Any expression will be here, will be replaced by a value coming from the assembly. This is the important thing. To be better informed, when you download the components, you will find this parameters tables is the name, with all that parameter. We use these three components to create an assembly. Let's create an assembly. standard millimeters IAM is the template. We go to tools. The first thing we have to do, we select document settings, units, and instead of millimeters we select centimeter. Every component is dimensioned in centimeters by using this procedure. Yes, tools, document settings, and selecting centimeter. This is the way to create a part with the other units. If you want to have the same units always, you have to use tiles edit. Okay, now we work in centimeters. Next is to create some parameters which are important for our iLogic work. The first is AS length, which we want to be a multi-value parameter. The first value is the maximum value, add, and the default value is not necessary. Okay, even if we have here only one value, this is declared as multi-value. The same with the next. The height, make multi-value. 80 is the maximum value, add, select this, delete, OK. And width, which has a maximum value of 50 centimeters, add, this is to be deleted. OK. We have to save this to continue. We save it under the name stand or modular stand, as you wish. Then we create the assembly. We go to place, but not using the ordinary tool, but place iLogic component. The first is the base, and we have to edit this table because we want to control this part from the assembly environment. Actually, we have to make this dimension length. Yes, this dimension length, which is this from here to here, to be identified with the assembly width. Yes, the length is width for the assembly. Assembly width. We select assembly width, and now they are connected, and they are considered the same parameter for both internal, external. Okay. The first object is to be placed grounded at origin, and this is the first object. The second one is here. Escape. We restart. Now place iLogic component, and then we place the pole. But you have to see here a new part, base 01. From the base we have now base 01. Why? Because we create an iLogic assembly. You'll see the same doubling of the other components pole if you use place an iLogic component. Now this is the pole, and its length is the height for the assembly. Yes, length as height. Okay, one is to be placed here and another one here. Escape. The last place iLogic component is the crossbar. You see pole and pole 01. Its length is length for the assembly. Yes, length. This is the same, length with length. Okay, we place 1, 2 crossbars. Then what is to be done? To constrain. We use the tool constrain, the insert, we select this arc and this arc. They are placed together. Apply, and the same for the other. Apply. But if you exit from here, you see that this is not final constraint. What to do? We use mate flush for placing these two in the same plane. Apply. To the other, the same. Apply. Next, we use the same insert for placing this arc and this arc. Apply. And also this one to this one. Apply. Then we use mate to place this axis on this point. Apply. Same up here. This axis on this point. Apply. The last is to place the other element, which is this one, here. Everybody understands this kind of relationship. This is to be placed here. Apply. And bottom is not fixed. You see, this is free because only 5 degrees of freedom are constrained. The last one, rotation, it is not constrained. And we can use axis and point to do this. Okay, this is the construction. We save it again as stand IAM. Okay, and we go further. Now we go to iLogic. Click on this title and let's see the rules. As you can see, we find here some rules. What do they contain? They contain only one statement. The parameter length from the base is to be assigned with the value of AS width. the length of the base to be the width of the assembly. This is the meaning. Save and run. The next is similar. The length of the pole, which is height, in fact, to be assigned from the value of as height. And the last one is also statement with the length equal to length. Good. Now let's go to forms and let's create a new form. You know procedure from the previous tutorials. We give it a name, modular stand, to know what is it about, and then we drag the three parameters to the form, as you can see. Each of them becomes associated with a combo box. This is all we'll see after. This value is 150, the length, the height is 80, and the width is 50. Okay. If we click here, this dialog box appears, but there is no values here because we didn't place them. Let's place them. Yes. To do this, we create a new rule. The rule name is list values. All of them are lists of values. Yes. Okay. And now we have to associate parameters with lists. To do this, we go to parameters, set list, double click, and we receive this object with a property. The parameter is D0. Where are the assemblies parameters? They are in the user parameters because we created them. You remember, in the assembly we created these three parameters. Double click on D0 and double click on length. Yes. Now we have to replace these default values with our values, which are 20, 40, 60, 80, 100, 120, and the last is the maximum value we already used. Okay, let's go to the next. We can copy this in the next lines. And once again, we can copy this line twice, once, twice. And the next parameters are the next also here. Yes, the values for the height are 30, 40, 50, 60, 70, and the last is the maximum value. We established these values, of course. Here is missing a comma. Good. And the last has, these are arbitrarily values, you know. You can choose anything you want. You want 1 kilometer, you place there 1 kilometer, no problem. 20, 30, 40, and maximum 50. Okay. Now, by running this rule, we'll find in the I'll save and run, and you'll see. We'll see the values in the parameter table. Save and run. Click here, and as you can see, they are placed there, and the effect is obvious. Let me make this smaller to see the result. If I select 150, we have the previous situation, but we can select anything. Yes, let me keep that after I modify to be the same. You see, this is the width of the assembly or the length of the base. You know now. Good. Let's go further. I think you can imagine what happens now. If I click here, instead of a unique value in this text box, we'll find a list. This is the list. Each one has its list. And if we select another value from the list, we have the answer here. This is what I presented at the beginning. You can do this with each parameter to see how looks the part, the assembly. Is very interesting and is made by you. Nobody was here but you. Good. What about the drawing? I want to have a drawing. Yes? Well, you can create a drawing to see the results. The first thing to do after opening the template is to change the units. Click on the Style and Standard editor. Be sure to be read right, and at the units, instead of millimeters, place centimeters. Save and close. Nothing happens, but we'll see. Now I place the stand, the modular stand, with the scale 1:10 to be around the number. Yes, and with a projection. Okay, now let's apply some dimensions. One is the length, which is, yes, 150. The other is the height, which is 90, it must be 80, not 90. We'll see what happens here. And this is 50. The problem with the height is that the pole has the length of 80 and this has a height of 10, and it's normal to have here this value, but is not correct. We want AS height to be the value in the text box or combo box, not with an add. Let's go back to the rules, which are here at the pole. Double click on this, where we have to change something. We have to subtract from this the value of another parameter, minus the base is this, and its parameter is the width. Model parameters, the width is 10. You see, I apply here, double click, and that's all. This is all the change we have to do. Now the length will be the height, the length of the pole will be the height, the designated height, minus the value of the base, the value of width of the base. Yes, save and run. Go here. Something must be changed. Yes, it must be. We go back and we apply here, say 60, the height. Okay, is it 60 also here? It is. Yes, because now what value has the height results from the sum between the length of the pole and the width of the base. If we change here back the height to 80, we'll see 80. Yes, you see here. Good, very nice. And now what? Now we think to refine the procedure. Why? What is the procedure now? Open this. By the way, let me save it with all modifications. Yes, I agree, all of them. So the procedure works by opening this assembly, and the presentation is this, and then to remember that I have to click on iLogic and to click on modular stand. To make this automatically, I create a new rule, a special rule, with the name trig rule, a trigger rule. Yes, when I open the assembly, to run this rule. This is my intention. Okay, and now I go to Forms and I double click here, show form. Instead of this default name, I write our proposed name, modular stand. I know that this form exists. Save and run. You see, this dialog box appears instantly. But how can I make this to function? Now the problem is I have to run this, run the rule to see this. But to make this automatically, we go to Manage, Event Triggers. Yes, and this is the dialog box, the new dialog box. We have here all our rules, and here we have the events. Which event I want to trigger this rule? Open document. I drag this rule in open document. After I open the document, this must be activated. Okay, good. Let's save again. I close this, I close also this drawing. Save change, save, and now I double click here to open the stand IAM. When I open it, the dialog box appears. Then I select parameter and I see what happens here. This is all for today. Bye bye.